video. In this video, I'm going to show you how to implement a decision tree in a class imbalance dataset. The dataset which I am using here is sourced from Kaggle. It is basically about how can we predict if a transaction is fraudulent or not depending on 30 given features. It's already principal component analysis done on the table, the dataset. Okay, and after this, I'm going to show in a pictorial format how the data is being used in the decision tree in the model by exporting it, and I'm then going to explain how there is the overfitting problem of the dataset and how it is remembering the data rather than learning from the data. In this video, I'll explain every step, whatever I have written on the screen, step by step. Okay, then let's get started. Here is the Jupyter notebook. I'll link this Jupyter notebook down in the description. Here are all the libraries which I have imported. I have used pandas and all these sklearn libraries, and there's a Graphviz for the plotting. Okay, so then here there's a read CSV command. What this does is it reads the CSV file and stores it in a data frame, pandas data frame, from where we can implement other scikit-learn libraries on it. Okay, so here I have done a splitting of the target and the feature. X has a 2D feature matrix and Y is a one-dimensional target matrix. Okay, so X is a 2D, so that's why it's a capital X, and Y is a small, so it's a small. It's one dimensional, so it is small. And X is df a drop class, and axis is 1, and Y is df of class column of the data frame, df data frame. And now I'm printing the first 5 features or first 5 rows of the data frame, which are these. And here what I have done is I have used a function called train test split of this sklearn model selection. Okay, what it does basically is it gives training data and testing data in the proportion which we have given it, like 0.2% of the data, 0.2 fraction of the data is in the testing, is for the testing part, which we can use later after we have trained our model using this train datasets. We are going to use these train datasets to train our model and use these test datasets, data frames, to test our dataset how accurate it is and see if there is a overfitting problem. Is our model trying to remember whatever we are being fed to learn to it? Okay, there's X, there's Y. We have given the feature matrix and the target. This test size, which can be anywhere from 0 to 1. This random state, and there's a stratify variable. Stratify, what it does is it maintains the proportion of the target variable, which is the Y. Like target has zeros and ones. 1 is for if it's a fraudulent transaction, 0 it's for a non-fraudulent transaction. So the distribution of fraudulent and non-fraudulent transaction in this training dataset and this testing dataset is same as this test size. Okay, so now we use this decision tree classifier. We have this object CLF we are using entropy criteria to decide which feature are we going to use first in our decision tree. And here what I have done is I have fit the data training x and y, and ypred stores the predicted value of this test data set. So I'm going to execute these. This is taking a little bit more. Decision tree is a complex process. For us it is complex, for computer it is long. Okay, we just wait a minute. Okay, it's done. Now we can find the accuracy and the recall score. I have already executed it before making this video, so that's why it's already printed here, but I am going to do right now is execute it again. Okay, now we can see accuracy on the training data, it's 1, like it's 100% accurate. Whatever we have fed into the prediction model, it's remembering the data rather than learning from the data. But the accuracy on this thing also we can see it's 99.92%. But here we have to not just go on the accuracy score, we have to see the recall value for it, because it's a class imbalance dataset. Recall value is also quite good, 72%, but it can be made better if you are using some other classification model like logistic regression, and also random forest will also do a very good job on this. Okay, so if I execute this command, it will show me a tree, how it is implementing. Okay, so okay, here is the tree which is being implemented inside the model. So it's very hard to exactly figure out how the data is being divided. So we are using this Graphviz function to export the file, export the tree, decision tree. This is the exported file. First feature, depending on the entropy, it is V14. We have 30 features, out of which the computer decided, because of the entropy score, to classify, to make this starting of this classification with V14. Okay, so we got this, and the explanation for this is this stores a dot format file. We but directly cannot interpret the dot format file. That's why I am converting it to a PNG file, which I can use it for the visualization. Okay, this is the file name, and this is view, like it popped up, so it's view true. You can use it or not use it. By default it is false. Okay, what I'm going to show now is the overfitting problem. It's an overfitting problem because the accuracy on the training data which we get is 1. It's 100% correct. How can it be 100% correct? It shouldn't be done like this, because it is trying to remember the data rather than learning from it. What we actually need it to do is learn how the pattern is going, but it is remembering the data. So this thing can be simplified and corrected by using random forest. Random forest is another algorithm. If you want the explanation of how the random forest works and how this decision tree works inside the algorithm, I linked down a very good video of a very popular YouTube channel, StatQuest. I really like its videos. Okay, then that's it for the video. Thanks for watching, guys. Have a nice day.